Hi, I'm Larry Johnson. I am a professor here at Texas A&M University, and today we want to talk about the respiratory system. We want to talk about the superior conchae, the olfactory epithelium, swell bodies, larynx, trachea, pseudostratified columnar epithelium with goblet cells.
Here we see olfactory epithelium on this side and that side, a bony structure here, a rich lamina propria there, rich vascular supply, and we can see the olfactory epithelium has no goblet cells. So the respiratory epithelium has goblet cells, but the olfactory epithelium does not. It does have glands that discharge on its surface. Bowman's glands will discharge on its surface. So if you look at a cross section of the turbinates, 1, 2, 3, as we see here, the olfactory cells will be here on the top, but you also have the middle and inferior conchae, which have, or turbinates is another name for them, and they have respiratory epithelium. So you have olfactory epithelium and respiratory epithelium on through there. And as you see, the air comes in and it will swirl. And what happens is the air spins, and as it spins, the dust particle, which is heavier, gets thrown against the side and gets caught in the mucus by the centrifugal force of the air moving. Is one of the ways it cleans the air. So the nose is very important in cleaning the air. It also has blood vessels in through there that are known as swell bodies, and that closes the airflow down from one side to the other side. If you ever had a cold and had to breathe through your mouth, you know how dry your mouth will get by breathing constantly. Same thing happens to your nose. So every 30 minutes, you need to switch the airflow from one side of the nose to the other side of the nose, and that's done by the changing of the swell bodies that are located in through there. Also, there's a countercurrent flow. The air is going in and the blood is directing toward the opening, and that warms the air as it goes through. And here we can see this is body whorls. You can see those turbinates in through there. Olfactory cells will be located in through there. Air will be swirling around through there. Dust particles get trapped in the mucus to get out, and so there'll be mucus lining all in through here. There's some blood in there. It should not be in there. And here we can see the respiratory epithelium on these turbinates. Let's say this happened to be an animal here, human over here, and you can see the swell bodies. You can see the swell bodies here, and these swell bodies, when they fill up with blood, they close the airflow into that one side. So you're breathing out of one side for 30 minutes and then the other side to allow it to rehumidify. If you've ever seen these sport players, they have this thing they call breathe right. I call it breathe wrong, because you're not supposed to breathe out of both nostrils at the same time, but it's okay for a football game. But that's what it does. It holds your nose above the swell bodies, so you're able to breathe out of both nostrils at one time. It's not good for all the time. It'll be okay for a football game. Here we see olfactory epithelium and respiratory epithelium. On this side, we see the swell bodies, the rich vascular of the swell bodies, and the olfactory epithelium with the support cells and with the nervous cells that are detecting. And we also see the Bowman's glands that are located in through there. Higher mag show you those Bowman's glands, and some of them discharge on the surface. You see the olfactory epithelium, rich vascular supply, but also see these nerves, big nerves that you can see here. These are nerves carrying the information from the olfactory cells to the brain. Now, coming down from the oral cavity, you have the esophagus. The esophagus is very important because it regulates flow of air down the trachea or down into the larynx and the trachea and the respiratory system versus the digestive system. And being flexible, it has elastic cartilage. And you can see the elastic fibers. There's a chondrocytes in through the elastic fibers in the matrix material. But most of the respiratory system has hyaline cartilage, and the hyaline cartilage provides flexible support to the respiratory system. It holds the airway open, yet not rigidly open, and it can be adjusted somewhat flexible. So here you see hyaline cartilage here, hyaline cartilage here. This is the thyroid cartilage in through there, conchae cartilage in through here. There's a true vocal cords, the false vocal cords, and if you come down here, there's this epiglottis. You come on down, this is the false vocal cords and the true vocal cords, and through here, what happens in the sound is the vocal cords are closed when you're talking, air blowing through there vibrates seeds, and that's what makes the sound. But you see the hyaline cartilage located here, here, and here, as opposed to elastic cartilage up there in the epiglottis. If we look at the larynx, we can see this is from the top going down. This is going to the trachea. In through there, we see the false vocal cords. This is the false vocal cords. And then we have the true vocal cords in through there, which has stratified squamous epithelium as opposed to respiratory epithelium here and here. And you'll be able to see a transition between those types. You can see the transition right here from stratified squamous epithelium, protective type epithelium, to the respiratory epithelium. And through there, there's a muscle, which is a skeletal muscle, because you can control them. You can see glands in the lamina propria. And so here we see a hierogmatic of this region right in through there. You can see the respiratory epithelium, the stratified squamous epithelium, the true vocal cords. You can see the cartilage, hyaline cartilage, the muscle. This is skeletal muscle that you would see glands and the false vocal cords that you see. Another view of that, you can see that the cartilage helps hold the opening open, and you can see where it does that. And because, as I mentioned to you, it works in no vacuum, so you have to have a rigid structure to hold the airway open, or it would collapse in the vacuum. And so we see the hyaline cartilage in through there. The pericardium goes around through there. You can see we see ducts and glands producing serous and mucus secretions that will humidify the air, and we have respiratory epithelium on the surface of the trachea. And here we see the trachea. We just see in the bottom part of the trachea, there's the esophagus here. You can see on either side, you can see this is artifact in there and there, but we can see the hyaline cartilage, and the hyaline cartilage between these tata is bridged by this smooth muscle. So this is a smooth muscle bridge here that can reduce the size of the opening of the trachea in case you need to cough out something. To reduce the size of it would increase the velocity of the air coming out. If you've ever been around a horse, when it blows his nose, you can know that you got sprayed because he was able to generate a lot of force associated with that. The respiratory epithelium, there's also elastic fibers just inside there, inside here, inside the respiratory epithelium. There's also glands, and we can see mucus and serous glands in there contributing to the, now this is muscle here of the esophagus. Here we see the trachea of a monkey, hyaline cartilage again, perichondrium, submucosal glands, and you see the respiratory epithelium. And note it has a very, very thick basement membrane in through there, much thicker than is typical. The goblet cells, as we can see, and you see a hierogmatic of that. You see the ciliated cells, the goblet cells with their secretions coming out, the basal bodies of the cilia, the cilia projecting on here, very thick basement membrane, rich vascular supply. You got plasma cells in through there in the lamina propria to make antibodies against whatever your antigens that are being exposed by breathing in air. If you look at the respiratory epithelium with the scanner electron microscopy, you can see the ciliated cells, these are individual cilium, in through there. You see microvilli on the goblet cells, and this is a mucus secretion of this goblet cell. You can see the secretion itself. So you got the conducting portion of the respiratory system, and you have a respiratory portion. Part of the conducting portion, we have the bronchus. So you come from the trachea to the bronchus, and here no longer do you have a horseshoe shape. You have plates, and these are cartilage plates that we see in the bronchus. When you lose those plates, you become bronchioles. So this, without the plates, would be a bronchiole, and this is a terminal bronchiole, and then that opens to a respiratory bronchiole, and then the alveolar, because it opens up to the alveoli and the alveolar duct, and these are alveoli located here, which is the same as these air spaces, and you would have capillaries in the wall, just as we see there.
We want to acknowledge the original source of images, drawings, and figures that might have been used during this presentation. This is the end of the respiratory system, the superior conchae, olfactory epithelium, swell bodies, larynx, trachea, pseudostratified columnar epithelium with goblet cells.